at identifying each of these as either natural, whole, integer, rational, or irrational. For the first example, you have the number 10. Now, looking at our definition from the notes, you know that 10 is natural. I'm going to put N for natural, because I don't have room to write all of this. You know that it is also whole, because it has to be a positive number for both of these. This is positive. So whole also includes the number 0, 1, 2, 3, 4, etc. So that is also a whole number. And then we know that 10 is also an integer. It could be negative or positive. So it's also considered an integer. I for integer. And we know that you can make this into a fraction. That's why it can be classified as rational. Rational numbers can be made into fractions because you could put 10 over 1 and still equal 10. So R for rational. It is not irrational. Irrational is a decimal that keeps going on and on and on with no pattern. Let's go to number 2. You have 1/5. That's a fraction. Guess what? It could be rational. It's not a natural number. It's not a whole number. It's not a whole number either. So it's not considered an integer. This is a fraction. Moving on to the next thing. 35, square root of 35. Well, we know that the square root of 35 is between the square root of 36. Square root of 36 would give you, it's a little bit of a lag. Sorry, guys. Square root of 36 is 6. It's not working out here, but let me just write 6. Take this off. And the square root of 25 is 5. This is somewhere in between. Everyone punch in the square root of 35. And when you punch it into Google Classroom or your calculator, it's going to keep going. This is going to be called an irrational number. I for irrational. Again, it's not natural because it has to be a whole number. It's got to be a positive number, and the whole number is also a positive number, so it doesn't work out. And this also includes 0. It's not an integer, so it's going to be irrational. Last one over here. If you have a negative 14 divided by 2, you end up with a negative 7. That is an integer. But guess what? It was also written as a fraction. So it's integer, comma, rational, because fractions are rational. And that's how you do these ones. There's not any work to show. You're just classifying them.